If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture on gate analog electronics series. So today we'll be solving three questions, question number 113, 114 and then 115. Okay, then let's try to solve these questions. If we see question number 113, what they are asking. In the wind bridge oscillator shown in the figure, what is the bridge is balanced when? So if you see what was the condition for bridge balancing a bridge in case of AC circuit, Z1, Z2, Z3, Z4. So this potential and this potential should be same. So here you see, if you see these two are legs, so this is the, if you see Z1, Z2, suppose Z3, Z4. So if you see this is Z1, Z2, Z3, Z4. And these are the two potential that is connected. This one is one between these two and this is between these two. So these should be at same potential, here also same. If this should at same potential, then it will oscillates. That is the transition point, you can see through which the oscillations occur. So for balancing this one, so again the same condition Z1, Z4 should be equal to Z2, Z. So what is your Z1? So this is the condition Z1, Z4. So this is my Z1, Z2, Z3, Z4. Okay. So Z1, Z4 should be equal to Z2, Z3. That is the balancing condition. So Z1 is R1 minus 1 by J omega C1. You can put S also and later you can change to omega C1, or you can start with this one. And Z4 is your R4 and Z2 is equal to, that is R2 in parallel with minus J by omega C2, because it is 1 by J. So that's why I'm putting minus. And this is actually J by, that's why it is minus, because J is in the denominator. If you take in the numerator, it will be minus, then R2 minus J by omega C2 multiplied by R3. So if you do this one, I think you can do this one and you can separate real and imaginary part. So I'm not doing it. You separate the real part, that is J parts, and so you separate the imaginary part. If you do this one, then you will find one equation of this fashion. I'm directly writing the expressions. So once you do this one, you will find, I think, omega square is equal to, or omega is equal to C1, C2, R1, R2. You do this one, you will find this one. Something minus will be there, so you will find this one. You will find omega equal to this one. So in all options, this is same only. C1, C2, R1, R2, C1, C2, C1, C2, R1, R2, C1, C2. So omega will not get any, will not do any change. So what is the next? Next you do, this is the, if you do, this is the real part. If you equate the real part from both sides, if you equal the imaginary part from both sides, that is J part, you will find something of this fashion: R4, C2, R2, then it is R1, C1, R4, then it is R3, R2, R3, C1. Now if you take LCM of this, because everything is involved, so obviously this will not be this simple, because here C3, R3. So you add this. If you take LCM this C3 and C and D, you take LCM for C, what will be the C? If you take LCM, it will be R3 by R4, and this side will be R2 C1, R1 C1, and then R2 C2. If you cross product, then this you will see that it is equal to this one, what you got in the equating the imaginary side. So that means your option C is the correct option. So 114, an oscillator circuit using an ideal op-amp and diodes are shown in figure. The time duration for the positive half of the circuit is delta T1, and for the negative half is for delta 2. Again the same condition. You see the capacitor will be charging through this RC path. So suppose if I take it is plus 5 volt, because output will be either plus 5 or minus 5, it will be oscillatory. So if it is plus 5, then what is the voltage you are getting? Because here it is not symmetry. Whatever positive voltage you get, in the negative you will not get the same voltage. Why? Because during positive of this diode will forward biased, so it will like that V0 is divided into 3 and 1, and if it is minus, then this diode is forward biased, then V0 will be divided into 2 parts. So if you think your positive, if you think your output is something of this fashion, sorry, this should be of same length, whatever. Suppose this is your same length, this is plus 5, this is minus 5. Then because the capacitor voltage, that matters for me. Okay, so in case of positive half, what is your V? What V you will get? Suppose this V I am marking here. So if it is V is positive plus 5, it is plus 5 volts, then what will be this V? Suppose this is my V. So what will be this V? So plus 5 will be divided into, if it is positive, then this diode, upper diode will be forward biased, so this voltage will be divided into 3 and 1, so it will get 1 by 4. That is your 1.25 voltage. So So this is the V level, suppose 1.25 voltage. So whenever capacitor voltage, because capacitor will be charging initially if I think it is 0, and if I think it is initially it is 0 and it is charging because V0 is positive I thought, so it is charging in this path through this RC. So when it will be reaching 1.25, then the transition will occur. So initially my capacitor is 0, when it reached 1.25, then transition will occur. 1.25 volt. Same. Now it is becoming now your V0 is -5. Now if it is -5, then which diode is forward bias? This diode. Then what is the voltage V now? Now V is divided by 2 only. 1 between 1 and 1 it will be divided by half. So -5 by 2. So it is -2.5. So it will be -2. Now capacitor will discharge up to a level of, because now it is negative -half. So now capacitor will discharge because now current will flow in this direction. So once current flow in this direction, now it will go discharged. Okay. Because earlier current was flowing in this direction, now we change the direction of battery. So this will come in this direction. So if current coming out of positive terminal, that it is delivering power, it is discharging. So capacitor gets discharged, and at what level it should go up to -V0, but it cannot go. It will reach -0.25. When it fall below that minus point, because it is -0.25. If it is less than -0.25, then again it will go to +B. Again transition will occur. So this will go to this level. So this is the level of -0.25. Again same, again from -0.25, when it become plus, then again it will start charging, and it should go up to V0, but it will stop at 1.25, because when it become plus, here it is plus B to 1.25. When it cross 1.25, then it will again transition will occur. So it will again come to 1.25. So this is the way the transistor will be discharging and charging. So the positive duration for positive of the cycle is plus T1. So this is positive half. So this delta T1, this is delta T1, and this is delta T2. We neglect the first part because first part we started from 0. We don't know from where it is, but it is the actual rhythm. It will swing between, it is always swing between plus 1.25 to -0.25, and it will keep on like this, charging, discharging, charging, discharging. Okay. Now if I do this one, what is my capacitor voltage here? Vc2. What is the equations? What is the final value? Because it was charging. So charging means it was positive V0 connected. So if you do nothing, if you keep the circuit open, then it will charge to positive voltage V0. What is its initial? Initial is -0.25. What is plus V0? That is 5 volt. It is charging with plus 5 volt. This is plus 5 volt. What is initial? -0.25. What is final? Plus 5 to the power minus T by RC. That is, suppose let me write it T1. So you need to find this time. So at what time it is keeping at this, what is this level? 1.25. So let me find at what voltage it is becoming, at what time it is becoming 7.5 to the power minus T1 by RC. 1.25 voltage. If you do this one, and if you take ln, I think you can do it. So if you find this is delta T1, suppose let me calculate. So it will 0.6931 RC you will find. So this is my delta T1. Similarly delta T2, if you see the voltage of capacitor, here the initial voltage is this is final voltage, because now it is discharging and discharging with minus V0, because the minus V0, once it discharges to 0, then it will again charge to minus V0. So if you keep it infinite, so it will go to minus V0, but it cannot go minus V0 because after 0.25 it is transition is occurring. What is initial here? It starts from 1.25. What is its final reach? It should have been gone like this up to minus V0, but it is stopped here because after that transition occurred. So this is minus V0, that is -5. So it is -5 to the power minus T by RC. So at what level? Let me, if I want to find delta 2, that means I am thinking when this Vc2 is equal to, when this voltage is becoming -0.25. That is my thinking. So this is if I take delta T2. So if you find delta T2, it will be 0.9163 RC. Now what they ask you to find e to the power delta T1 minus delta T2 by RC. So if you put it there, RC will get cancelled, and you will find e to the power, whatever you will find something, and final expression you will find 0.7999 I think. So it will be approximate to equal, or you will get 0.7999. So you write it 0.8. So that is your answer. So in the 115, what they are asking, the circuit of the figure shows a 555 timer. Now I am not going to discuss 555 timer, because again for that you need to draw this internal circuit, but you should know what is a 555 timer A-stable. A-stable means it is charging between 2/3 Vc to -1/3 Vc. So you should remember that T on and T5, because in case of on, this it charged through this RA and RB, and while in case of off, it charged only through RB. So the internal circuit I am not drawing. You can have a look in 555 timer. So you can directly remember also. This is actually the formula, or sometimes it's written on 0.7 also. RA plus RB. This is the charging time, and it's charged from -1/3 VCC. That is whatever its VCC voltage, threshold volt, to 2/3 VCC. In case of it is A stable multivibrator, because in both A stable means in bi-stable, it will have both transitions, and then -2/3 VCC to it goes to -1/3 VCC. Then this process keeps on 1/3 VCC and then flash, so 2/3 VCC to the end. So this is the way it discharges. It charge up to 1/3 VCC, then VCC, then discharge, then charge, then discharge. It is the way the capacitor gets charged and discharged. So I am not doing in that one. And if in case of TF, it goes only through RB. So it is again 0.69 and it becomes RB into C. So what is your time period? Time period becomes 0.69 RA plus 2 RB into C. So here this time period they have given, because they have given frequency equal to 10 kilohertz. That means this time period is given 1/10 kilo, because frequency is 1/f, time period is 1/f. So if you do this one, C is also given. So you will find the equation for RA plus 2 RB. It will be 14,400. And one more equation is also given, duty cycle. What is duty cycle? Duty cycle is T on by T. So T they have given already, and this is given 0.7. So what is T on? T on is this one. You see this formula, 0.69 RA plus RB. C is they have already given, and it is 0.75 into T is this one, 1/10 k. If you do this one, you will find RA plus RB equal to 10,800. Now you can solve these two. These are the two simple equations. If you deduct also, you can see directly you can get RA, RB. So if you calculate your RA, you will get 7.25, and then RB will be equal to 3.6. Slight variations can be there, because sometimes they take it is as 0.7 also approximation. So that is your option C. If you like the video, then press the like button and please give your valuable